Here's Jordi.
Thank you for the kind introduction. Okay, so I'm going to talk a little bit about perception in AGI systems. So far we have been mostly talking about the reasoning part of these systems, but I think there's more to it. Sometimes cognition is used to contrast against perception and action. I will be calling that reasoning because I think some other people refer to cognition as the whole package. I'm going to be focusing on perception in this talk, and but some people consider action to be basically perception in reverse. So some of what I say might also apply to action. So another definition, basically I will be using Dr. Wong's definition of general intelligence, which means that the system must achieve its goals using insufficient knowledge and resources, and it's general, so it does this in a domain-independent way. This means, among other things, that you want your reasoning system to be able to deal with all kinds of sensors and actuators, and not be tied down to any particular set, like for instance human senses. However, while a general system doesn't necessarily need to include any of these senses, it should support being connected to them. So I think an intelligent system should be able to support being able to use sight, hearing, touch, smell, taste. These are the basic 5 human senses, right? Does anybody have a 6th sense?
Yeah.
Oh yeah, everybody. I mean,
Yes.
actually, we have a ton of other senses as well. Well, I'm not going to go through all of them. Actually, there are way more than this also, because the last one is our internal senses, which is like hunger, being able to sense when you need to go to the bathroom, all kinds of internal processes. Now, of course, we are not the only beings on Earth. So, you have animals who also have different kinds of senses, like sonar or pressure detection or whatever. And of course, we are not constrained to the physical domain with our intelligent systems. So, an AGI could also have to deal with high frequency stock market data, or I also put language here because as humans, we always have to interact with language through some other modality, right? We have to use our vision to read, or use our hearing to listen to things. Welcome. But the virtual system could directly interface with language, although that doesn't necessarily make it easy. Should I pause for a second?
Sure.
I'll just wait until everybody sits down.
You might want to go back to your slide about cognition and reasoning, just to reiterate that point,
Yeah.
so you don't get questions.
Okay, yeah, so I started with doing some terminology. Sometimes cognition is used to contrast against perception, which is what I'm going to be talking about mostly, but I think cognition entails all of perception, reasoning, and action. Welcome. So I will be referring to the thinking part of the systems as reasoning, and not mention perception anymore, or cognition anymore. I will be mentioning perception a lot. And I also said that action is basically perception in reverse, so some of the ideas might also apply to action. Then, well, we use Dr. Wong's definition for intelligence, and basically there are a ton of senses that any intelligent system, I think, should be able to support. However, some of these might be slightly problematic. some senses, like for instance vision, audition, touch, sonar, natural language, are highly complex, low level, very numerous, high bandwidth, or throughput, I don't really have a good word for that, types of data. And these might be very difficult to deal with. So I'm going to be proposing, so this is the type of sense or perception that I will be talking about mostly. And the example that I will be using is vision mostly. I will briefly mention other things, but it's nice to have one example, and I think vision fits the bill because in our eye, one eye, we have 120 million rods which are used for like light intensity perception. And we have 6 to 10 million cones which are used for color perception. It's just one eye. Apparently, the image that we can take with our vision corresponds to a 576 megapixel camera. I have to say that this might be slightly misleading because these figures are coming from different sources, and this like 500 million pixels figure is compiled over a certain amount of time. So, you know, every 30 or so milliseconds our eyes saccade and we focus on a slightly different part of the environment. And then I think after a second or something, you have compiled this hugely high resolution image. And at the same time, information is transmitted to the brain at between 25 and 150 frames per second. So it should be clear that this is a ton of data, right? And furthermore, if you do this in an artificial system, you're going to be using a camera, which is pixels, and one pixel really doesn't tell you all that much. It's a really, really low-level feature. All of the visual objects that we can perceive in our environment are like built up in hierarchies, very high complexity. So this is difficult data to deal with. Okay, this is not working as well as I was hoping. Okay. So I'm proposing a sort of taxonomy. I mean, I put possible solutions, but I really didn't have any real solutions. I just want to discuss what you guys think might work and how some cognitive architectures are approaching this problem. It's also not a perfect taxonomy because there's a lot of overlap between all of the solutions, options. Well, these are the 6 options. I'm just going to go over them one by one. Okay, so the first one is really the most obvious one. It is to just directly connect the pixels, which are on the left here, to our AGI system, which is on the right. Well, this obviously has the problem that I just mentioned, right? Although there are actually systems that are pretty good at this. Some AGI aspiring systems are sub-symbolic, are very well equipped to deal with this type of distributed meaning that is there in the pixels. Because, you know, one pixel doesn't really tell you anything. It's just you have to evaluate a whole bunch of them together to actually get at what they mean. Some systems are specifically made for that. Also, some people believe that intelligence is basically just perception and action that has gotten a little bit out of hand. It's like perception on steroids. And I think systems like these are most deep learning architectures like Destin and hierarchical temporal memory. I think they have other problems, but they are fairly well equipped to deal with this type of data. On the other hand, the systems that we have been considering in our summer school mostly deal better with higher level data. We have seen this in the examples, of course. Usually the data that comes into AERA and NARS and even OpenCog is fairly high level. Of course, OpenCog is now integrating Destin, but before it did that, it really couldn't deal well with this type of data. Concepts are usually represented in a fairly local manner. I mean, one concept is supposed to mean one thing, as far as I know. Yeah, you need very deep, complex hierarchies, which means a lot of training data, a lot that can go wrong. And you know, the enormous amounts of incoming data can obviously overload any system. And you can easily see this when you don't only consider the fact that you'll get, you know, if you just do it directly and stupidly, I would say, you get like 500 million pixels in there, which is a lot, right? But what is even more is the relationships between all of those that you would have to represent in order to say something like, you know, if this mouse is over here and my visual field is still the same thing as over here, the relations between the pixels there are the same as the relations there. So that's just a ton of data. So the second option is basically meant to sort of deal with that. And the idea here is to have device driver or module or some kind of external system that can do some kind of pre-processing, that can translate raw input data to something that's more suitable to the AGI system. And in the case of vision, this could extract lines, blobs, I don't know, faces, words if it's reading. You can go pretty high or pretty low, just, you know, whatever you think is wise. In the very simplest case, actually, you could just subsample the pixels, because maybe, you know, you don't need 24,000 by 24,000 grid of pixels in order to make your decisions. Yeah, you could argue that this is more or less what is happening in the brain. Also, I think you'd be slightly wrong, because there are also basically arrows going back from here to there. But on the visual cortex, there are these areas which all process things in higher levels of detail, and even the eye itself already decreases the amount of information that is coming into it by 2 orders of magnitude before sending anything to the brain. Well, obviously one problem with this could be that you're potentially losing out on important details. Like if you use the retarded option that I just mentioned, of just subsampling your perceptions, obviously you're throwing away detail. And since this is not really a solved problem, it's hard to really avoid that, I think. Nevertheless, there are 2 ways in which you can do this. You can just encode them manually by a human. You know, a human can have opinions on computer vision and say, you know, what's really important are all the lines or the blobs or whatever. Or you could maybe have another sort of, well, not intelligent, let's say narrow AI type system there that can do slightly more intelligent feature extraction for you. And one sort of interesting option there might be to actually just use another instance of your AGI learning system there. So if your AGI is AERA, then just use another instance of AERA here. And that is explicitly specialized for dealing with vision. And then you can have other instances for other senses. And you would still have a lot of the same problems, I think. However, since they are each allowed to specialize, they might be a little bit mitigated. So which architectures use this? Well, as we've seen with S1, AERA used the pitch analyzer for the audio in order to slightly decrease the state space there. And well, I'm going to be using Destin and OpenCog a lot as examples. Probably not the best idea, but it's the only architecture that we've been discussing that actually had the perception integrated. So you could say, you know, Destin extracts patterns for OpenCog. Okay, so let's move on to option 3, outsourcing. The idea here is basically to just use a third-party computer vision system that does everything for you. You could say it's sort of a special case of the previous option because, you know, if you just extract really high level features, then you could say maybe that it's a fully fledged computer vision system. Although I don't think that's entirely correct because in this case, all of the concepts would actually have to be defined inside of this black box, and then it would communicate them to your AGI system. Okay. Well, obviously this is pretty convenient for testing out your system. You don't want to, you want to develop as little as possible basically and focus on the interesting parts. So it could seem like a good idea to just use whatever third-party software you can use and easily hook up to your AGI system. I don't think that's a great long-term solution unless you are specifically building a system that can benefit somewhat from general intelligence, but operates in a really well-defined domain. In that case, you can just make a general, or you can just make a very specific purpose computer vision system. If you know all the objects that it's ever going to have to detect, for instance, then it doesn't need to do open class learning and any difficult stuff like that. Because, you know, computer vision and speech analysis and all those things are actually really hard. They're actually so hard that in order to completely solve them, you would probably need this black box over there to be an AGI system itself. And just one example that's sort of used is maybe a speech-to-text converter that's used in AERA for S1. Okay, so the fourth option, maybe I should have put this last because you can actually mix all of the ideas, I think. The idea here is basically to use option 2 or 3, except instead of one module, you just use a whole bunch of modules. And you know they're going to make mistakes because, you know, these are difficult problems. But maybe if you're lucky, they're going to make different mistakes. So then your AGI can learn to detect the patterns in what the other modules are saying and maybe rearrange them in a way that it can actually make sense of what is actually going on in the world. Yeah, so it can mitigate some of the problems, and this is just what I said. I don't know if any systems that actually do this, but well, I don't know that many systems. So. My fifth option is interaction. The idea is to have an external module that is more specialized to, in this case, computer vision than the AGI system, but that interacts with the AGI system so that they can sort of perceive together. And the main difference between this and option 3 and 4 is this arrow that goes back in this direction. Because I think the type of top-down feedback that you could get from an intelligent reasoning system is exactly the kind of thing that you need in order to make your computer vision module over there actually work well. I also made the box a little less black, it's slightly transparent, because it's probably a good idea if these systems are at least based somewhat on the same concepts or speak the same language so that they can interact with each other better. Yeah, you know, like in the OpenCog team modified testing in order to be able to communicate with it better. Although I think the best example of the integration with testing is probably this one, where you just integrate vision module in this case into the AGI system. And then the pixels still come in directly to the AGI system, they're just processed by this specialized module which can easily communicate with all of the rest of the system. If you do this, then you have a vision system in your supposedly general reasoning system, which you could argue makes it slightly less general, but most people won't care because actually a lot of people are just targeting human-like intelligence. And if you look at I think this is actually true for most cognitive architectures. So they just integrate some type of specialized vision system in them. And I think this is the goal with Destin for OpenCog, right? And this is not right now implemented in AERA, I think, but conceptually you could implement a computer vision system in the master plan in Replicode and have that process all of the raw incoming data. Okay, so that is basically it. Yeah, I'd just like to ask you, the teachers, everybody, what you think is the best approach for NARS, AERA, OpenCog, maybe others. Just put the list up here again, or maybe you disagree with my taxonomy, it's also fine.
I mean, I think as you know, the boundaries between these categories are kind of fuzzy.
Yeah.
I think the way you laid it out makes sense for expository purposes, but then when you dig into it, it becomes a bit unclear what lies on one side and on the other. So I want to outline briefly. So here's an alternate approach to doing Destin type processing in OpenCog, which I also considered. So what we've actually done on the code level is taken Destin as a separate software system, a separate C code, and you run it, and then you run a frequent subtree miner on its output and feed that into OpenCog and so on. Now, what we could do, which would be roughly equivalent, instead of having a separate software process like that, I mean, we have a spatial data structure in OpenCog called the 3D space map. And you can take that 3D space map and you could view it in terms of a hierarchy of more and more abstract levels, like a Destin hierarchy. I mean, we already have the 3D space map is like the lowest level of the Destin hierarchy. So you can just build abstractions on that without too much trouble. Now, what Destin is doing is pretty much clustering and then passing information around in a certain way. Now, clustering, we have clustering implemented on the OpenCog guidance space already, right? So then in essence, you could implement a closely Destin-like architecture as a special purpose clustering and inference control algorithm on top of spatial knowledge in OpenCog, right? And algorithmically, that would be basically the same algorithm, but code-wise, it would be integrated, like inside OpenCog, rather than a separate block of code outside OpenCog. Now, I don't know what we'll actually end up with. I mean, it may be that we end up with that. The good reason not to do that now is that Destin can be run on a GPU. I mean, the current C code isn't GPU friendly, but we have an older CUDA version, and we'll eventually port the more recent changes into the CUDA version. Whereas OpenCog, due to various other complexities, the atom space won't run well on a GPU. Now you could, of course, make the 3D space map in OpenCog GPU friendly, even though the rest isn't, but then that becomes more complicated. So in that case, you know, the difference between interaction and integration comes down to more of a code level rather than an algorithm level distinction, and thus may not really be that essential.
Yeah, I think that could be right. It's just probably a way of looking at it. I mean, do you consider Destin to be part of OpenCog, or do you consider it to be like a separate thing, basically?
Yeah, I mean, that's I guess to me that's an uninteresting question.
Right, okay.
It doesn't matter. It does what it does. And also that's largely a sociological question too. The thing is, Destin was developed by Idemar Arel's students. So at this point, since Idamar's students are still working on it as a separate vision system, as well as working on it as well as their improvements being put into it for use in OpenCog, then we kind of consider it as a separate system, just because there are people working on it as a separate system. Now, if Idemar got sick of having students work on that or whatever, then the only work on that was being done by OpenCog staff. then in practice it would be considered part of OpenCog.
Right.
But yeah, that's sociological rather than fundamental about the algorithmic processes.
Yeah, I think it's about, well, it is in a sense sociological, if you think about it like that. It's, the way I think about it is, if you're integrated, then basically, well, you consider it really a part of your project, of your architecture, and well, probably you're working on it. And if you take the more the interaction approach, then maybe you would not be concerning yourself so much with this part, but you would really be making this part and perhaps something that can interact with a certain type of external modules.
So in that case, in that weak sense of integration, I would say what I have found is that integration in that sense is more effective than interaction. Because what we found with Destin is that I would have preferred the interaction approach because I would have rather not had one more problem to deal with, and revision is complicated. When we really got into it, we realized that to use Destin effectively in OpenCog, we had to make many changes inside Destin, which didn't necessarily impair its use as a standalone vision system, but which were different than what Inmar wanted to do, and which maybe were not interesting things to do from the point of view of a standalone vision system.
Right.
So even if integration includes something that also works as a separate module as well as within your architecture, if what makes it integration is that you're making changes in the perception system to enable it to work effectively with the rest of the architecture, then Destin is integrated, and then I think that conceptually integration is probably necessary, because I think all the different parts of the mind need to be adapted to one another to work. It's unlikely someone's going to build an external module that happens to meet all your requirements.
Well, the thing is, it's fuzzy, obviously. I mean, I do think there's a difference there. Like, if you consider it to be integrated, then you're basically free to do whatever you want with it, and you just, program it specifically for your own architecture. Whereas in this case, you would expect the external module to be a little bit more general. I mean, it would obviously have to support this, arrow coming back into it. So,
well, as an example, there's a flag in Destin now, so you can choose either to have each node have its own set of centroid patterns, or to have the centroids shared across the whole network. Now, Inmar prefers to have each node have its own centroid patterns, because that's, in his view, a better model of how the brain works.
Right.
We want to have common centroids across everything, because that makes it easier to do symbolic modeling of what happens inside the network. But rather than fork the code, we just made use of quasi-object-oriented programming. I mean, quasi, since it's supposed to be C-like code, and just made a configuration option to go between them. So it kind of breaks the distinction between option 5 and 6. And
well, the thing is that a lot of the other options
is breaking all the other distinctions too. That's the way these things go.
Yeah, well, I actually mentioned, I don't know if you were already here for that, but I know it's not a perfect taxonomy, and there's a lot of overlap and fuzziness, and I couldn't come up with anything better.
No, I think it's a useful. It's a useful sort of distinction to make, even though it doesn't fully work, because it points people's attention to the issue.
Thank you. Anyone else?
What is the back arrow? What data is going across there? Is that like extra queries about asking for more information?
This one?
Yeah.
Like I said, perception is really difficult, and usually I think a large part of the problem is that if you just go in this direction, you don't have any context information. So what you want is from an intelligent system to be able to tell you, what is going on. you can see two different, well, you can see a certain arrangement of pixels and interpret it in different ways depending on, you know, what you're expecting basically. Or maybe a better example would be, do you know this experiment where there's a guy saying blah, 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 and you see a video of him, you know, saying those words. And then there's another video with the exact same sound, but with him mouthing ga 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 or something like this, like slightly different lip movements. And then you perceive the sound that corresponds to the lip movements, even though it makes no sense. And although maybe this is also a bad example because it actually causes you to make an error, if you will. But this is the type of thing that is, you know, there's top-down information coming from the visual sense of seeing somebody move his lips in a certain way that affects your auditory perception. And that's the kind of thing that I'm talking about here. And in this case, I guess it would cause you to make an error, but usually it will cause you to do the right thing.
So like, okay.
A way to summarize that is that there is quite a bit of crosstalk, although that's not maybe the right word here, between the senses. So nature seems to have, for most species, connected the senses up so they can actually influence each other. So that would, but that's an argument actually for connections between modalities. The down arrow could be various things like threshold shifting, making it more sensitive or less sensitive in to certain things than others, etc.
Yeah, it could also focus its attention, or, you know, if you're looking at it to the comic strip or whatever, then you can sense depth basically due to the configuration of the people in the image. I mean, it's a 2D page, right? But you still know which one, what is in front of something else, even though if you have the same size character, then those, well, you don't perceive pixels, but let's say pixels, they will mean different things to you compared depending on where in a room somebody is standing or next to what. So you will get top-down information that helps you with the meaning and the perception. So how do you think this type of thing should be approached for NARS?
Yeah, I need a long discussion for this. It's a big topic. But I summarize my points like this. First, perception clearly is necessary for AGI. That's not a problem. Even though I haven't directly working on perception in the narrow sense. But second, I have a strong feeling that perception and action should be actually studied and handled together. In traditional AI, this two, to me, in my case, is two separated. Actually, in my discussion, I introduced the concept of a sensory motor interface of NARS in layer 8. You will see that perception actually is together with this action, both handled as system operation. So when you say perception, you more concentrate on the kind of feedback or what you get. Okay, but still is something initiated by the system. It's something driven by the goal and so on. So, yeah, one thing I'm going to do in NARS, which makes it different from many other systems, is to completely kind of like handle this perception and action altogether. But still acknowledge the difference. When they say something is mostly an action, something is mostly a perception. That's one, I think, the first major point I want to address. The second point I want to address is, even though I think perception is completely necessary, I don't think any specific sensory channel or perception, especially the human-like one. I don't think any of them are absolutely necessary for AGI. Even though for practical purpose, of course, we want to pay more attention to human-like sensory motor, like for example vision. Okay, I have no problem to think about AGI with no vision at all, but it's perfectly intelligent.
Yeah.
But it will use some other input-output channel.
So I agree with that, and maybe I didn't mention that, but I think that an AGI system doesn't need to have vision. But if you build a general purpose reasoning system that can be used in basically whatever domain, then it should be able to support being hooked up to a sense of vision,
That's
right?
what I mean. That's what I mean. Yeah. Eventually, you need to be hooked up with something to communicate with the environment. That's for sure. But what that something is, I don't think there is a fixed group of sensory motor you must support to be considered as AGI.
I agree, but so vision is an example, but
Yes, I see that.
so if you have NARS, and I say so it has to support being able to be hooked up to vision, right? So does it support that right now? Because I think this, like I described, this is very complex, low level, etc. Data. So I mean, of course, in theory, if you had a huge amount of computational resources, then probably it could work, but and a huge amount of data in order to learn. But do you think there's something special needed to deal with that type of sensor?
Yeah, the first thing is, of course, a well-designed interface. That's my idea, to provide a kind of a uniform and general purpose sensory motor interface. Then all the sensor and actuators can be just plug and play as corporate operations that specified within the system. But the implementation of that operation is completely in the outside. So it's kind of like what you have actually some kind of combination of your option 4 and option 5. Option 5 is the point that is not a pure input. Many people take perception as a pure input. To me, it's always both an input and output. So it's always a two-way, even though data flow in one direction may be stronger than the other, but overall it should be a two-way. So I strongly agree with your option number 5.
Okay.
But another thing I like number 4 is it should allow different level of description. Even let's say take vision as example. In the future, if we want to equip vision in NARS, I think maybe there are several different plug and play modules we plug into it. Actually, accept information at different level of granularity. I don't want to, so I don't really like the outsourcing approach, say that, you have a completed module for vision, which I'm not, I don't think it's going to work because a lot of vision, high level, say, object recognition, actually depend on what you think. Okay, you don't have a box which tell you what is out there. So for example, attention allocation will have a very strong impact on what you see. On the other hand, of course, if you just go with level 1, you directly take in the raw signal, clearly that's not a very good idea. But I don't mind to have some kind of mixture of so my point is you don't have to make a single commitment with a certain level of description. You can allow multiple things to get in. Another point is I agree with Chris. It can be across modularity. It's always a bad idea to have more than one channel, even though some of the channel may take the same modularity but at different levels of description, and some of them completely separate modularity. I think that's the way to go, even though it will make things a little bit more complicated.
Of course, all modalities would be connected through the system itself, right?
Yes.
So, do you think there need to be more connections directly between them, or just
No, I would rather for the system itself. Of course, if they can interconnect with each other, that's okay. But most of the signal or information integration will be done by the AGI.
It seems necessary. I mean, if you want to emulate anything like human-like perception, it seems necessary to have integration at multiple levels of the perceptual hierarchy between different senses. So it may be that the most critical is integration at the higher level of perception interfaces with cognition, but you also need perception at the lower levels as well to emulate, like, I don't know, a primordial human hunting in the forest or something. I mean, seeing and hearing are working together at a rapid level without need for interference of cognition. Now, to what extent you need that for AGI is a subtle question that I don't know the answer to. Because the question is, to what extent is the rich cross-modal integration of different sense modalities used as the basis for metaphors and other guidance for cognitive processing patterns? And that's not entirely clear to me. Like, could you just as well build an AGI whose sense modalities were completely distinct? What would that AGI be missing that we gain indirectly and metaphorically from this? And that's my gut feel is that you could build an AGI that way that would work fine, but we just have a different perspective and be impaired in some sorts of analysis of the everyday world and real world activity. But that's more of a gut feel than something I have evidence for.
So to make it more concrete, I mean, you're going to use Destin for vision and for audition,
Yeah, we would
right?
cross-link the lower levels of the hierarchy. We wouldn't
You just connect one Destin to the other one directly?
Well, specifically in a Destin node, you can augment the input vector of that node with extra information. So the way you do cognitive control of Destin is to augment the input vector to a given Destin node with information that comes from the cognitive layer. And we've prototyped that in simplistic ways, like when you use Destin to feed information to a supervised learning algorithm, you can take the inferred category and feed it as an additional input to each node.
But then you are going through the cognition.
Yeah, but what I'm getting at is, in the same way, you could augment the input vector to say a level 2 Destin node with the inferred state, with something indicating the inferred state of level 2 of the audition hierarchy.
Okay.
And what's the exact right way to do that? I mean, maybe what you want to do is, if you've done frequent subtree mining on both the perception and audition hierarchies, you take the recognized subtrees that occur in level 2 of the audition hierarchy, and you add a token indicating that subtree and append it to the input vector of a node on level 2 of the Destin vision hierarchy. So then you're not feeding like the whole fire hose of auditory information into each level of the vision hierarchy, but you're feeding a slightly abstracted version of each level of the auditory hierarchy into each level of the vision hierarchy, which we have not remotely done yet, although Destin has only been used for vision. Idamar's commercial system, HDRN, which is quite analogous to Destin, has been used for audition also. So it's not that remote to do that from what we have now, but we've not played with it yet. It would be interesting to see, like if you were trying to understand what someone's saying in dim light, then you're like coordinating, seeing their lips and hearing the sound, and that's where you would expect this kind of integration to play a big role. But then how critical is that?
Okay. So, any comments on AERA's view?
Of course, at some level, if you increase the system's generality on the perception side, you're increasing the overall capability of the system in its entirety. Because yes, you can make up for some lack of raw data, let's say, by reasoning, but only to some extent. Going all the way to bits trickling into the sensors and being very heavy on the intelligence side versus having a very dumb intelligence and big fire hose on the perception side. These are two extremes that I don't think, frankly, don't make much sense in isolation, actually. I think there's some sort of medium. And so a system that can learn to use any sensor that you plug into it, the faster it is at learning that and the better it uses it. Of course, the more general it is, and probably in some way, at least on some scales, would it make some people in this room say, yes, okay, it's a better AGI system than some other one that can't do that.
So would you prefer interaction or integration?
I prefer the one that actually there are two axes at least that you're trying to optimize on. One is sort of the engineering side, which is what we're trying to do. We're trying to build systems. The simpler they are at building and maintaining and using, the better. So a pipeline architecture is far preferred if you can get away with it. But I don't think you can get away with it, really, for the kinds of perception that we'd be interested in having an AGI do.
Right.
And I think probably an AGI is going to be more useful for doing real-world tasks and making decisions than, let's say at an oil rig, than using it in the back corner to think about, say, philosophical theories. It just doesn't, it'll come, but, a bit later maybe.
Yeah, I think I need to clarify a point I just made, just to avoid misunderstanding. When I say, I want the sensory motor to be plug and play, it doesn't mean, when you plug it in, it will work perfectly because it's an AGI. What I mean is, when I say it's an AGI, it's the last part, the design of the kind of the core system doesn't depend on anything about the special property of the sensor and actuator. But after you plug something into it, the system needs to take quite some time to really be able to use that organ effectively. And then after that, in a sense, it becomes a special purpose system in terms of the perception capacity. And when you plug that out, you plug in something else, then it will need to redo the learning altogether because each sensory motor device can be very different in terms of the details. So the learning aspect and also the organ-specific knowledge will actually turn that part to be kind of like special purpose. So that's what I mean. And also another point is, after you plug in a different sensory motor mechanism, the system's conceptual, the content of the system's concept will be very different. It will actually see the world or participate the signals in a very different way. So I will not be surprised if the same nerves, if you plug in different organs, after a while they have completely different point of view about the world. And also they will have some difficulty to communicate with each other just because their conceptual structures are not completely compatible, even though there will be some overlap. That's what I mean.
Okay. Anyone else?
I have two questions. First one is about from the cognitive sense perspective, the interaction between the perception and the internal part, like the core part. I think the first one is if I already know what a triangle is, and then I will use my knowledge to lead the perception to find a triangle, and the perception part will use its ability to provide to help me to find the triangle, and this is a kind of interaction. But I think another interaction is the perception when I have no idea about the triangle and I see the sheet again and again, and sometimes the perception it can't like the perception side. Well, there's something worth noting. You'd better create a symbol for it, and then I had like a triangle symbol in my mind, and that can be manipulated by a rule-based or symbolic system. I don't know if the second part is also included in your.
The fact that you have to make new concepts for new things that you're perceiving, it's exactly the kind of thing that makes computer vision extremely difficult. So I think, well, the solution that I would think might work is to have a more specialized system, you know, extract these patterns and then give them to the AGI system, which analyzes these patterns and then hopefully is able to see some similarities between maybe other triangles that they've seen, and then eventually come to the conclusion that this might be an important thing to remember and create a concept for. So I think that is why I think vision is AGI hard. I think you need an intelligent system to be able to decide these types of things.
By patterns, you mean patterns already know, or patterns?
No, just
patterns.
Regularities in the pixels and in the history that this has seen before.
So I don't know if like Bastin or deep learning system was for this, like to create define some features to represent.
Yeah, I don't think so, but I think that is why the subgraph mining is implemented. So the system will. So I think, if I understood correctly, OpenCode will be continuously analyzing the patterns that occur in the higher levels of Destin and mine the ones that occur most frequently.
Yeah, I mean, we actually use a frequent subgraph mining algorithm, which is subtree mining algorithm, which is not ours. It's an open source code, and that looks at frequent subtrees in a large set of destined trees, and then recognizes those subtrees when they occur in a destined state, and then those subtrees and their relations to the subtrees are exported to OpenCloud, which can then identify very spatial relations between the subtrees. So OpenCloud kind of looks at an abstracted view of what's in the destined state hierarchy, and then OpenCog can do inference and then further abstraction from there. I mean, that's not the only way to do it, but in practice, it's a fire hose, like we've been saying, right? So I mean, the state of destined is it's a large number of floating point numbers that are changing all the time, and in actual practice at the moment, yeah, you could represent all those in the OpenCog atom space, but in practice, it's a shitload of low-level information.
Yeah, you have the exact problem that.
Yeah, so in practice, we recognize frequent subtrees and then identify those subtrees, and then the subtree miner could become the bottleneck. I mean, I get the feeling that just based on having looked at the subtrees we get for recognizing objects, the subtrees seem fine. If I want to tell chairs from tables and so on, tell if someone's walking. Now, if you talk about, say, face recognition, which is not recognizing that, not face identification, but actually distinguishing Jordi's face from your face or something. Now you have glasses on, that's easy. But in general, that would be hard to do accurately given the subtrees we get right now from the destined hierarchy, looking at pictures. And on the other hand, if you look at what people do for face recognition, they don't use generic image classification systems. They hand code features, typically for faces, and eye features, and lip features, and nose features. And the human brain appears to have that kind of specialization as well. Like the human visual cortex has specialized feature detectors for face recognition. So that will be a case where either something like OpenCog actually has to look at the detailed floating point data on the destined hierarchy, or you have specialized feature detectors, which is how the human brain solves the problem. Then those specialized feature detectors would augment the frequent subtrees, which are more of a generic feature detector. And it would all be fed into open cloud Azure space. I mean, in principle, you could learn face recognition without specialized feature detectors as well, and that's an interesting research.
I think you just, I mean, in a sense, distinguishing between two human faces is like fundamentally the same problem as distinguishing between a chair and a human face, right? It's just a level of detail.
Well, but in essence, all AI problems are fundamentally the same.
All right, okay.
They're just maximizing functions with different levels of difficulty.
Yeah.
That's why AXE solves the AI problem. We should all go
No, but I think, so for instance, if you would connect to slightly lower levels of your hierarchy in Destin, then you might be more able to distinguish between faces than you are right now.
Probably. Actually, to be honest, I think you can handle that using a frequent subtree mining approach, but probably not using the exact frequent subtree miner we're using now. It might be more of a surprising subtree miner approach with a different objective function for which subtrees to extract or something. So you could probably do something like that, but it is a significantly harder problem. But as you say, people, I mean, for a human baby to learn that without the genetic predisposition that humans have for it, I mean, we might just have to look at a hell of a lot of faces extremely carefully until we get that. Kind of like a dolphin researcher eventually learns to tell one dolphin from another, based on the shape of the dolphin and the different curvature of the fin and so forth. But it takes a lot of work. You don't get it naturally like you do the human face.
I have a semi-philosophical question concerning the machine perception, but just a semi-philosophical. Just we know all patterns that are very important. Well, Destin system or other systems, they need to achieve patterns, some abstract features out of the raw data. But patterns, they are not semantic nodes in the web construction. They have some images. It just, for example, the image of triangle is different from the node triangle. But the image of triangle as a pattern is still more abstract than raw data. So it looks like the media between the two. So I'm just thinking about how to represent this strange stuff. So far as I know, Pace Logic or NAS Logic website can do that because NAS can take image as a node, right?
Yeah, or it's a term, technically. That's I think it's an important point, that is, I still have the feeling that the traditional distinction between cognition and perception draw the line too sharp. Actually, it's a continuation, especially in a system like NARS. You see, a term is not the name of an object. Okay, if you do that, perception and cognition are different. It's just the name. Actually, it's the name of an internal data structure. Okay, well, in that sense, an image, as far as they get into the system, is a term, and you can define, say, inheritance. Say this image is a special case of that one. You can do reasoning on it. So actually, I have a conjecture that is the logic of cognition and the logic of perception. Fundamentally, they're probably the same. It's just for special function, of course, like for instance, face recognition. You may need some special knowledge or special tuning of the mechanism to make it efficient. But in terms of the principle, to me, what people call pattern in NARS is nothing but a compound term. Okay? It's a term consists of other terms as components, so that as far as the system can build that kind of thing, I use the experience to select one which is useful and repeated and so on. And then you can see that the hierarchy of perception and the hierarchy of cognition is not that different from me.
This is what I know. What I'm interested in how it is being done in OpenCog. Because OpenCog has a different perception system that you Destin. So logically speaking, there are only two choices. The first choice is Destin achieves some patterns from raw data, and to represent those patterns in atom space or something like that. But how can atom space represent image? But another logical option is just keep those patterns on the level of density, but a high level of density. But those patterns are ready to be achieved by atom space or higher inheritance. So there are two options. I'm now.
Actually, if we really dig into it, so there's in effect a database of destined states, and the subgraphs recognized from the destined states, which right now is crude. It's just a bunch of flat files, but that needs to be more sophisticated. But anyway, we do separately store a record of the visual experience, and it's not all put into the atom space. I mean, you could put it on the atom space, but in practice, what will happen is the stream of what's being seen is put into the atom space. But because it's a computer, you can also just separately keep a big file of everything you ever saw and everything you abstracted at the low to intermediate level from what you saw. And then the cognitive mind, the atom space, could later dip back into that, which is not something that humans can do, because our brains aren't quite built that way. It'd be more like having a video recorder integrated in your head, but also a hard drive that has a snapshot of your visual cortex every 5 seconds attached to your head. And that's an option that a more brain-like AGI architecture wouldn't want to use. It's not much like the human brain. But this is an issue for destined as a pure deep learning architecture. In its current form, neither destined nor any other deep learning hierarchical temporal memory type architecture is good at long-term memory. Like, none of them are good at retaining a visual memory that they haven't seen for a year. Like, they would all forget what their mother's face looks like when they go on vacation. I mean, I think you could change that by giving the centroids or whatever other patterns are in the nodes of the hierarchy a long-term importance as well as a short-term importance, like an open cloud. So you could re-architect them to have that kind of persistent lifelong memory. But currently, no one has done that.
Is it possible to establish some links which can overact the two domains, the destined domain and atom space, in order to establish the long-term memory of images?
I don't understand. A third kind of representation?
Just because you say that the current stage of destined not good at a long-term memory image, it will immediately forget the mother's face.
Well, that's true, but we can just save its states in a database, and then you have long-term memory. I mean, it's not very cognitive, but it works. I mean, the issue is more that it all comes down to efficiency issues, because if you have the destined hierarchy store centroids for everything it's ever seen, the more centroids it stores, the less efficient it gets, because it has to search through all of them each time it sees something. But humans are sort of like that too, I think. I mean, if you're away from a certain environment, it takes you a little while to reacclimate to it somehow. Like if I haven't been out in the forest for a long time, I'm not used to it. And then somehow my system acclimates to it within 15 minutes or half an hour. So some things are somehow stored in more of a long-term sense, and then they become more ready to mind. So there is a question, though, of how much of that sophistication do you pack into the visual hierarchy, and how much do you leave in the cognitive engine, and how much do you put in some database. And these are honestly in OpenCog, these are decisions we make largely based on pragmatics, like how fast things are when you load a lot of information to them and so forth. But then the human brain may have evolved largely because of its own pragmatics.
I think we should move to the next topic.
You want to take a break?
Good question. Yeah. Let's take a 10-minute break. Back here, 15:20.
Okay.
It's Jordi or Jordi?
It's Jordi,
Yeah, I know.
but in English it's Jordi. Okay, so this talks about curiosity. The reason I came to this topic was basically a question that I asked Eric when he was telling us about AERA. What does it do after it has trained for 20 hours on spoken interview data? Because, of course, it does this in real time, which is very impressive, but I mean, probably it doesn't have all the resources to do all the processing that it could possibly do at that point in time. So maybe I thought it would help to just, reflect a little bit on that knowledge, just like I think we do. I mean, lots of people say they have their best ideas in the shower, right? They're not currently interacting with anything, but they're just thinking about what they saw and improving their knowledge in the absence of actual data. So what does AERA do in this case? Well, basically Eric said it would just sit there twiddling its thumbs, which is kind of, a waste of time. And he said that the way to fix that in AERA would be to give it a sense of curiosity, a drive to learn, to explore the unknown. And I think that could be really useful because, as we know, any intelligent system must try to achieve its goals with insufficient knowledge and resources. So that means that it has to really manage those resources well in order to be successful. The resources, a couple of examples of resources are time, input, and energy. Time should be obvious. There's a limited amount of it, and you want to respond as fast as you can to meet deadlines and stuff like that. Input might be a little bit less obvious. We cannot constantly observe everything that goes on in the world. There's a limited amount of input that we can perceive, and therefore we should seek to make this input useful to us. And finally, there's energy, which in this case translates to like computational resources, like speed, memory, working memory, and hard disk memory should be distinguished because working memory is much more precious to AERA. Okay, so how do we implement curiosity in an AGI system? Jürgen Schmidt, who has formalized the theory of artificial curiosity, where he considers two parts of an intelligent agent. One part is the predictor or compressor. And what it does is it learns from the system experience to represent all the input data that it has gotten in a more general, compact manner. This basically helps the system to behave better and gather knowledge. And then there's the reinforcement learner, which guides the system to make decisions that result in rewards, basically. So the idea of curiosity then is to use the improvement of the predictor as a reward for the reinforcement learner. What it will do is it will prompt the reinforcement learner to seek out situations where it can improve the predictor and learn. This helps to utilize this scarce resource of the input of the system because learning is obviously useful to future performance. And according to Schmidt-Huber, this explains art, music, humor, science, fun, and active learning. The idea there being that in order to be successful in, let's say, music, you have to make something that is at least slightly novel. I mean, if it's too simple, then nobody will like it. On the other hand, if you just put together a bunch of random sounds, then nobody's going to like that either. So you have to just innovate a little bit. And that is what his idea of curiosity is based on. For the agent to seek out situations that are slightly different from what it has learned before, so that it can learn more about that. So one important question is, how do you measure learning progress? To be honest, I haven't really had all the time to look into what tree-to-roof is, but I found another implementations by AGI and Kaplan, and they point out that it actually doesn't matter how you measure this. If you just say, well, I'm going to look at the prediction error of my system and compare the current prediction error to the error that I made a while ago, then this system will alternate between seeking out very simple environments and very difficult environments, because then in the simple ones it will really improve its prediction rate, and it will get that sweet reward for a reinforcement learner. So you don't want it to be able to just go from a difficult situation to an easy situation and get those benefits. So the way that they tried to solve that was to classify situations, basically. They only want to measure improvement in a certain type of situation. So if their example was of the non-working system would be an agent constantly running into a wall, which would be difficult to predict what would exactly happen, or one just stopping in front of a wall, and then it's just pretty easy to predict. And in their solution, they would classify these situations so that the predictions of stopping in front of a wall would only be compared to earlier predictions that would be made. And in that way you can measure the progress of the system better, and you avoid this type of exploitation of your reinforcement learner. And it's called the intelligent adaptive curiosity system. And the classifiers for the situations are adapted on the fly, so that when a lot of situations get the same classification, it splits it up and considers two different situations. I think what is important to see here is that you shouldn't, or you should have a fairly fine-grained control of evaluation over your predictors. Okay, so how can we implement curiosity in AERA? Well, curiosity is going to improve prediction, because that's basically how we just defined it. And in AERA, all models are predictors. So that's really great, because first of all, it allows a really fine-grained progress measurements that we have just seen are pretty important. And second, to improve those models will basically improve everything in AERA. So it will also help not just with utilizing the input well, but also with managing time and energy better. And finally, when the system is curious, it might seek to either falsify models, which could really result in their deletion, and then of course you don't have to consider them all the time, so this will free up time and energy, or vindication, so it will confirm that the model is really good, and then it can schedule it for compression, and then in the future it will take up less working memory and less time to evaluate. The system will still be stored on hard disk, so I guess the total amount of memory increases a little bit, but the important part is that it frees up working memory. Okay. Unfortunately, it's not quite that easy, because you have this exploration trade-off. You want your system to do useful things, and not just explore and be curious all the time and just do what it wants and learn stuff if it's never going to use what it's learned. So there's a certain trade-off there. So Bas Brink and Chris and Eric and Ruben Sweeter and I think another guy proposed this work-play-dream framework for intelligent agents. You can guess what three parts it consists of. So we have work, And during work, the system is concerned with exploitation of what it already knows. This makes sense, right? Because when you want the system to be working, it's using its computational resources to accomplish the goals that you have set for it. And then, of course, there's play, which is the time for exploration. And the system, during this time, can look into stuff that seems interesting and seek out situations where it might learn. However, you kind of want to prevent that with curiosity killing a cat. So it needs to be supervised in some way. Yeah, I figured it's late in the day, so we have some bad humor. During playtime, the system may need to be supervised, at least to this, according to this framework, to prevent it from killing cats or itself, or even to just guide it in a fruitful direction for exploration. Because, I mean, it could just do anything, right? The definition of exploration is basically don't do what you think is best and see what happens. So that could go in directions that are not entirely helpful to the system's goals during work. But then, of course, there are times when no human supervisor is available. Although I have to say it's not entirely clear to me why the system couldn't just try to avoid really dangerous situations. I guess it would still be useful to guide it, but I mean, you don't have to take any random action if you're exploring, of course. You can just avoid the things that you think will kill you. And this should get more effective as the system gets more experience, because probably in the beginning it's not so good at judging those types of situations. So anyway, if there's no supervision, then the system can dream. And during this dreaming, it can do all kinds of useful things like batch processing. For instance, in AERA, good models will be compressed at some point, which invokes the C++ compiler, which takes some time. So it might be useful to do that kind of thing during dreaming. It can flush the buffer. So this is, I think, kind of related to my original question. If the system has been working or playing for a while in real time and it has a lot of experiences that it couldn't process at the time, but that were actually pretty interesting, it could just go through this buffer and evaluate those situations later. I guess it could do some conservative exploration maybe, and if there's any time left, it could just plan what it wants to do the next day during play or work, or what it wants to explore. This actually looks a lot like a human day, right? Well, I guess in some ways it is, but you have to consider that potentially it could do all these things at the same time or in any order it wanted to. You just have to decide how much processing you want to give to each of them. It could just have a very small urge to play or to be curious, and during work it will generally do what is best to achieve its goals. But if there are multiple options, it's just going to take the one that it will learn the most from. All right. It's dreaming of Martians. That was mostly it. I just had some questions for teachers, and maybe we can discuss these things together. So I was wondering, why does AERA need this type of curiosity when it seems that, for instance, NARS doesn't? Because as we've all seen in the demo, if you give NARS a couple of facts, then it will basically keep reasoning about them indefinitely. Yeah, let's just consider the questions one by one. So, why does AERA need this type of system, or why does NARS not need it? Or is there some kind of curiosity system implemented explicitly or implicitly in NARS that...
You want me to answer first, or Chris, or Ben?
you can argue who.
Okay. Yeah, I will answer first. Number one, curiosity I think is crucial for intelligence. Number two, I don't think it's a separate process within AGI system. So what I'm doing in ours is, for me, it's nothing but derive the question. The system, you give the system a question, the system derive a whole bunch of questions, which is initially looks like a sub-question. But if this chain of derivation is long enough, actually in the end, all those questions looks completely have nothing to do with the original question. They will be taken as the system's own question. And those questions will, to a certain extent, guide the system's work. So the system is kind of like looking for some kind of information which looks like have nothing to do with everything else I have told it to do. So people may say that's curiosity. But if you check the logic, there is no separate curiosity generation process. It's just a byproduct of backward inference. So that's one point. Another point is I fully agree with you that one problem in traditional AI systems, especially some agent system, is the assumption that the system is kind of like sitting there and just passively accept whatever the outside pull into it. That's clearly the wrong picture. But in AI also people have already proposed the idea of active learning. So the learning process is not sitting there and waiting to get information, process that, but to go out to actually explore. And I think that's clearly related to the curiosity idea. It's driven by some question and some goal. But if you check where they come from, I don't say that's completely random or arbitrarily taken. It must have something to do with the system's experience with the other goals. Even though the relation is not that traditionally logical, especially it's not pure deduction anymore. Okay, something maybe just remotely related to what internal drive or external question have asked the system to do. So that's another point I want to make. And third one, I think this idea of work, play, and dream is very interesting, and I kind of like agree with the idea. But in ours, I would rather treat it as a continuum. So for me, work is the situation where the system concentrates on high priority tasks. And play and dream, it's kind of like, there is nothing urgent, so you can explore your own interest. But I don't handle it as clearly separated state or mode. It's a matter of degree. Dream maybe is slightly selective, but in the current system, it's kind of like after a while, if you don't ask the system to do anything, the system is always running. Okay, it's just you can say it's dreaming. Okay, it's working on its own questions, which may look not important to us. Also, the working mode is slightly different because when the priority is low, actually the threshold becomes lower. So the system will begin to explore possibility which looks, completely wrong or very unlikely, compared to when the system is focusing on a high priority problem. In those situations, the low priority, low probability options will be usually ignored. You just say that's very unlikely to happen. I don't have the time for those. But when there's nothing better to do, it doesn't matter if you wander around in your mental state. So my attitude is, yes, I agree with that, but I see it's more like a matter of degree rather than a clearly separated state.
I think it's actually also not completely separated in AERA, but what I want to ask you is, do you think if S1 would have had different goals, it would not have sit there twiddling its thumbs, and maybe it would have generated sub-questions all the time and not need an explicit mechanism for curiosity?
Well, in the current state of affairs, it wouldn't do anything more than what it was built for. The thing is, curiosity is, we name it curiosity, but it's in fact a side effect. It's a side effect of an inference rule or more that we want to add in neuron. And it is actually what Lars does well now, is to ask questions. And so far we don't have that. But once we improve a little bit the set of inference rules, then we will have that. The measurement being the first derivative of the success rate of numbers. And since the granularity is so fine, then we can completely intertwine the work played during DAST, just depending on the urgency of the goals. So it's not day and night.
Okay. So what about OpenCog? If you were trained on something and it doesn't have all the time to evaluate everything it sees in real time, does it like later think about it and improve its performance anymore? Or?
Yeah, sure. I mean, that will be guided by, I mean, that's complex. So it would depend on what the goals of the system are and on the underlying the dynamics of attention allocation. But I mean, if you have a goal of learning new things, as well, a novelty goal, which could be similar mechanisms to your curiosity, for that matter, then if the system's background thinking about some topic is causing it to learn new things in its own mind, it will be motivated to keep on doing that. Then there's a question of how will it balance that versus some other goal, like getting more goodies in real time, which is a similar issue that human beings have. Now, the deeper thing that an OpenCog system could do, which gets down to some things I mentioned during Cosmo's presentation this morning, is let's say that OpenCog really wants to do something, like say get a treasure that's sitting in some building over there, right? And thinking about how to get that treasure, it may not actually be learning anything new at all. It may just be very boring and going over the same useless ground again and again. But you'd like, if it really wants to get that treasure, you'd like it to be able to just keep thinking about it anyway. And that would require a mechanism of special goal-driven importance that is described in the OpenCog book and a paper, but it's not in the code yet. That's a kind of sophisticated form of delayed gratification, basically. So that, I mean, the curiosity mechanism in OpenCog is explicit. So it's just, you have a bunch of top-level goals, and one of them is novelty, which exactly the best way to implement that. I mean, I don't know, we do information theory stuff like everyone else, so I'm not quite sure the right way to tune that, actually. But does OpenCog twiddle its thumbs? I mean, it could. That would be coordination for the Hanson RoboKind robot. I think it could probably do it. But in general, the nonlinear attention allocation could cause a system that just, by twiddling those parameters, you could make a system that had the personality to just do nothing unless there was some immediate stimulus. Or you could make a system that was driven to think about new things. And that would be sort of personality configuration of the system, which is not that hard to do. Now, does it require downtime? No, at the current moment, it does not require downtime. Now, I could see how you could play with that in a lot of different ways, though, and it would be variant, like the individual personality of the system. I mean, you could make a system that went nuts every 3 hours, in a sense, right? Like it was, you could make the balance of goals change, so that for much of the day, it was focused on doing useful stuff. Then periodically, the weighting of goals would change. It would just want to think of novel things and generate cool ideas for an hour. Then we'd go back trying to achieve things in the world. And that would be interesting. Would that be helpful for the system in terms of like generating more new ideas that it can then use to achieve its goals? Would that give it something that you don't get just from thinking creatively in the background while doing things? I mean, actually, I don't know. the system is too complex to answer that analytically. We'd have to experiment with it and see. I mean, what I thought about was, in a distributed system, make some like separate modes on particular machines that are just indulging in wacky creative thinking and then pushing their most intriguing conclusions to the main end space. So more like you had a separate lobe of your brain that's dreaming all the time and throws the cool stuff into your main mind when you have time for it, which is probably a better way to do it than having to like lie on your back completely out of it for a certain period of time each day, which is extremely inconvenient. I mean, the memory consolidation that the human brain does while dreaming and sleeping, I feel like the analog of that, an open cloud system can just do in real time at the same time as thinking. On the other, I guess, if it was in a situation where it had to do maximally responsive real-time response, like if there's a tiger chasing the robot, that may be so intensive that there's no room to allocate any processor to memory consolidation. But that's going to be an uncommon situation. So I tend to think the need for downtime is an artifact of bad design, basically. And I mean, you should, in a computer architecture, if you're not trying to emulate the human brain in great detail, you should probably be able to do these kind of consolidation and imagination backgrounds concurrently with the other things that you're doing.
So I have a command, maybe two commands. The first, maybe first idea is maybe in open cloud system we have some a series of high-level goals. One of them is novelty, and the novelty is connected to curiosity. But maybe we can do it in a simpler way. For example, I believe that curiosity is very related to abduction. For example, when we are doing abductive inference, and sometimes we simply cannot get a result. We cannot find any solution to that to explain the given phenomenon. And if that happens, we will have the feeling of curiosity. So maybe in our human brain, there is hardwired a mechanism just responsible for sending out some chemical components to have that feeling when that kind of situation happens. So we can model it in computer science. Another is maybe I get the conclusion, maybe by deduction, maybe by induction, but the conclusion looks very weird and very abnormal so far as my experience is concerned. And that result can also trigger that mechanism to work. So this is another model to do the job. I have another related command to Peiwan's response to that. Yes, maybe we will say that there is a continuous. I found that the continuity between working and playing is very obvious. But dreaming is something quite different. You talked about dreaming may be a process of planning, dreaming may be a process of reverse learning. I'm just thinking about another question. We can also do planning when we are not dreaming. We can also do reverse engineering when we are not dreaming. So why dreaming is so special? I will give another kind of things, maybe against your, not the same as your intuition, but on the contrary, it is against your intuition. In some sense, when we are dreaming, we will lose a normal sense of curiosity. For example, when we are not dreaming, we have the naive physics in mind. We know something will not happen. For example, if somebody can resist gravity and fly in the sky like a witch or something, okay, like Hollywood, everybody will say, wow, how curious. Why is that happening? It doesn't have an engine. It doesn't have wing. It's simply totally against the one. But in the dream, why does that happen? Maybe you are not be aware of the abnormality. We will say, well, we'll accept that, just like movie Inception. So in this case, I think the point of dreaming is when we are dreaming, our cognitive system, like a PLN web constriction, is detached to, for example, the testing system. It is detached to it. It will not accept and it will not invoke some higher level checking program in order to check the consistency. of the whole data. It will just do some local job and disembed it. And maybe this will give some chance to let the system to create some pathways. When if these pathways are prohibited, when the system is not dreaming. Okay, because it is disembodied, it will have more freedom to create something new. So I believe that this kind of procedure would be not very related to curiosity. You will not have the feeling of curiosity when you're dreaming. You just do it and let the thought lead to any place that it can lead you.
Right, so if you, well, first of all, I think, well, these terms were probably chosen to be analogs to human states, but they should probably not be taken too literally. And second, if you look, if you say dream is not so much related to curiosity, I think that is mostly also what they were saying. Actually, I added this one, so this, no, that doesn't work. I added this conservative exploration because I think it should be possible, but the other things are not actually that curiosity related.
Right.
Imagine the system goes down for a while, do some data mining, try to find some patterns in the stuff which is expected.
Yeah, and also, I'm not sure if this is correct actually, but I think that the dream state basically is available when play is not available because there's no supervision. So then it can do these things. It doesn't necessarily mean it cannot do anything else at the same time.
So yeah, I'm curious about what you think is the best way to formalize novelty or curiosity as a goal in a system like OpenCog. I mean, I kind of conceptually understand a bunch of ideas bouncing around about this, and I'm actually not sure the optimal way to do it.
Well, I haven't really thought about it that much, but the way they do it is they measure how well their system can predict their inputs, basically, and the outcomes of that is well observed, I think.
It's not exactly true.
Okay.
What we do instead is we measure the first derivative of the success rate of the models.
Mm-hmm.
Means in fact that if we learn a little bit more, and just a little bit more, or just a little bit less, it is deemed as not very interesting.
Mm-hmm.
But if we learn suddenly more and more, and significantly so, or we learn less and less, it is also interesting, then the situation in which those models are fired is deemed interesting. Then it's easy to extract a pattern by that, change it a bit, and act accordingly. Well, but that's in our system, very not
Yeah, it seems like there's a problem here, similar to something Cosmo was asking about during my previous lecture. So there's a distinction between, the Kolmogorov information, like measures the degree by which you can compress something. And then I tried to introduce a long time ago something called structural complexity, which gave more bonus points for being to compress something in a lot of different ways. And it seems like there's something similar going on here, because if you're just measuring how well you can predict your next symbol that you see, or whatever it is, I feel like somehow we should get credit for being able to predict that by a host of different methods. I mean, many different patterns going on in it. So I'm not...
So if something is really simple and you've already seen it a lot, then you don't get any benefit for predicting that correctly because...
Yeah, but that's a boring case in the regular life of an AGI system in a complex environment. So I'm kind of thinking about it pragmatically from what to do in an OpenCog system. I'm not sure how the theory works out, but like in actual case of like OpenCog in the game world or in the robot environment, I think if you reward it just for predicting what's going to happen, then asking it for curiosity or novelty isn't really it's not adding that much, because we want to predict what happens anyway. Then as Pace says, asking for curiosity and novelty is kind of irrelevant, because for achieving its goals, it's going to predict what happens in the world, and in the world anyway. I mean, I feel like if you were somehow asking it to have a variety of different ways of predicting what happens, that's closer to asking it to be creative and inventive in its way of thinking. I'm not sure that's exactly the perfect way to formulate it either, but I feel like you need some diversity reward there, similar to how in Moses evolution we try to get a diverse ensemble of program rather than just the fittest possible program.
So I think if you do the exploitation path, then you follow the path of, you know, what you predict will be the best for you, and this is probably based on situations that you've already seen. So you will not get a high curiosity reward. You will get a higher reward for deviating from that path, because you don't know exactly what will happen, but you might actually find something that is more useful there, right?
Yeah.
So you do get, I think, this diversity bonus, basically. I mean, like, not having any diversity is just following what you already know, right?
That's one way to not having diversity. Yeah. Yeah.
Anyone else? Okay.
Okay, well, if not, then let's have Michael up here.
Oh, Eric is just showing me.
Come on in, Rob.
Faish. I've been working on a project for a while, probably a couple of years, and I've got special permission from my wife to spend every Tuesday evening on it. And a special permission from my wife to be here, because it's not actually easy to get away from the family and everything. So what I'm doing, rather than going, full AGI from the beginning with, trying to make something which is incredibly intelligent and stuff, and I start with something simple and then incrementally make it intelligent. So we had Chris's little line thing here. And I think we had, what do we have, a rock first, or an amoeba?
Amoeba is fine.
Amoeba. And we had, I'll use my fish. Dog. And I think you had at the end of the line, and then you stuck a human here. Jeez. Brittle chalk.
Welcome to the club.
Chris too now.
Yeah. And he said, look, we can go from here and here and here and here, and look, we've achieved AGI. And I'm thinking, well, why don't you just do this, And then you can stick, AGI researcher up here. So step one, so rather than start with something which is really, really complicated and, doing things like, dialogue and working in virtual worlds, and do something really simple to start off with, and then add things to it as we go. So, fish, the namesake, Faish, artificial intelligent fish, swims in a two-dimensional world. It gathers food, and every time it gathers food, it gets a little reward. So, hang on, here it is over here. It's one of these windows. So I'll pull it up here. Open the fish. There you go. There's my little fish. Now it's just swimming in circles. My fantastic AGI is leading edge. It doesn't work. So all it does at the moment is swim around in circles. Well, we've got some food. There you go. But anyway, I've been working on it. I was hoping to get it working. I managed to write the fish little interface on Thursday, and I was working on the evolution modules over the weekend, and I didn't quite get it going before I came. So, but that's the idea. All I wanted to do is swim around and get the food. So if it sees food, sorry, I'll explain a bit more. So I'll just take this rule out, click the rule, and then run it again, and now it goes in a straight The fish has a direction. It's got 3 eyes, 1, 2, 3. And all it basically does is it can see things either in front of it or on either side of it. It should be able to see the food, so it's got sensors. And the control mechanism is basically just going forward and turning. So in theory, it should be able to turn. Like I was doing circles there before. So I'll stop it before it crashes. But it makes it an interesting challenge. Firstly, it's time-based. So it's what I've done is used logic as a basis. So it's basically I've made a prologue environment. Prologue doesn't handle things changing very well, so that's one of the first challenges I have to deal with. Secondly, data overload, streaming in. You have to throw away half of it, you have to decide what to keep. The rewards it gets are not good heuristics because it swims around at first before it's learned anything, before it's learned how to find food and so forth. It gets like 0 reward, 0 reward, 0 reward, huge reward when it gets food, and then 0 reward again. So it has to work out what's causing the rewards. And of course there's also a lot of scope in the fish because an optimal solution, you can imagine if it's got food everywhere, an optimal fish could sort of, after it's been learning enough, it'll be able to sort of, form a plan and go around and get the food in some sort of optimal order and have memory and so forth. And it's really hard to do with general AI because what I'm trying to do is implement it without the AI having any prior knowledge whatsoever of the environment it's been put in. It has no idea that it's a fish. All that it knows is that it's got 3 sensors and a motor. And has to try and work out
the dimensionality of the world.
It doesn't know anything about the world. It doesn't even know it's 2-dimensional. And so it has to basically work it out for itself. And in this case, it's getting something working should be fairly easy. If it gets something on this sensor, turn left. If it gets something on that sensor, turn right.
Yeah.
It's a very, very simple thing to try and do, and it's still not working. That's okay. Who was saying it's leading edge?
Well, if it works, it's not AGI.
Yeah. But you can imagine that sort of thing. I could probably write a solution for that in probably less than an hour in Python or something if I had to. And so when I've done my fish, when it's working, it's not, but when it's working, then I'm going to make a dog, and it's going to be so amazing, and it's going to have a 3D world with physics and a simulated robot body. And you can go and say, go make a stack of blocks, or go fetch me this, or go navigate this maze, or whatever. And I've got some ideas written down on how I'm going to, how the algorithms, I've got all the algorithms on paper, and how to work out how to get it to run on a cluster of computers, and swap things to and from hard disks, and so forth. And basically, the result of that, what I'd be implementing is a logical database. When I started on this project, I went to have a look to see what sort of logical databases there were. And you had Prolog, which I saw at university. Prolog's a very, very interesting language. It's one of those languages that would be incredibly awesome if it didn't suck so badly. Seriously, it's like in third year computer science. They go, right, we're going to teach you Prolog. Here you go, fire at the interpreter. And you fire at the interpreter. And then in order to put knowledge into the system, you had to stick it in a file and then import it. And then you could only run queries in the interpreter. And it's, and then you've got this depth first search thing going on. So when you write Prolog rules, where's the chalk one? I can get rid of that now, we've got the point. You normally have, I can't remember the terminology they use, you have conclusion, if, some premise I think there were, premise, comma, whatever, full stop. And so you write your program like this, using a whole bunch of these statements with variables in here that get unified and so forth. And when the interpreter runs, it first tries to find a solution for this premise, and if that premise can be found as the conclusion of some other premise, then it does a depth first search trying to find that, and trying to find that, and trying to find that. And that's great if you don't mind making sure that your program is well ordered, and that, with these sort of, cuts, operators in the middle, which is sort of cheating, I think. So like I was saying, it'd be a fantastic language if it didn't suck so much. So I've got rid of all those constraints and made a language which is a fantastic version of Prolog that doesn't work. So this is my grand plan on how to make the intelligence. Step 1, work out how to store knowledge. Knowledge representation, it's an area of study. Store 2, generate a whole bunch of random theories in that knowledge. Step 3, discard the nonsense, keep the good theories, and use it. So it's running an evolutionary algorithm or a genetic algorithm on the knowledge itself. And of course it's going to work because, random search is a viable search option. Totally going to work. Doesn't work. Storing knowledge. I was the guy that sent an email out in the AGI, one of the AGI mailing lists saying, what is this concept? I've got a language. How good is it? How can I tell how good it is? So you've got this concept of expressive completeness, and I have to give credit to somebody whose name I've forgotten for the term. It's the ability of a formalized language to represent and manipulate any human thought. And some philosophers here probably goes, oh yeah, Socrates or something. And basically, I want to know more about that. That's as far as I've got with it. I've got a name for it now. What's the rest of it? And basically that results in knowing the limitations of the language. If there's a concept that I can't represent in the language, then the AI can't work with that concept. And so the language I've invented is Prolog. I call it Squl, S-Q-U-L, because, Squl of fish. And as I was writing it, I was making sure that one, it can handle the nonsense knowledge that we're going to be generating in step 2. It doesn't get stuck in infinite loops like Prolog does at the drop of a hat. It can handle multiple queries at the same time, and the whole thing is modularized, so you can make it piece by piece. And so the language, I'll probably just skip over this and just go straight into some examples. It's all just labels and values and if-then statements. So a statement is a whole bunch of labels and values. Labels, so you have a label value, label value, label value, full stop. Labels always start with the lowercase letter, and the values can be atoms. Everyone knows what an atom is from like Lisp or something. Yeah. Variables, and the variables are bound within a single statement. So it's one variable. There's only, it's closed within one statement. I allow nested statements, which is kind of a necessity. And then of course you have to be able to stick integers and strings in there. And then the interesting bit is this is where you have the Prolog clauses. I use if that and if that and that. And these are labels and values as well, so you can write out the statement to query if there are if-then statements that match something. For example, appending to a list, how many people here know Prolog? One?
I used to know Prolog.
Used to know Prolog. You know Prolog well enough to understand this anyway. So this is appending to a list. The way I'm representing a list is using a list is a head and a tail, and the tail is also a head and a tail, and that tail is a head and tail, and sort of pit the end. So what this is saying is something. If if you append that head and that tail to this variable, then the result is a list which has that head and that tail, where that tail is defined as appending that to that recursively. And I'll just show that I'm not talking out of the bodily cavity. So, no, that's the wrong one. Where's pen list? There we go. So there we go. So that's the same thing. Half of these are actually, you can ignore it. That's metadata, that's metadata, that's metadata. So these are the two statements here. Appending the end of a list to a list results in the list. And appending, make it bigger, something and something and something makes something. And so we'll take this example here. You've got two lists, A, comma, B. That's the end of the list. And, oh, so these are unordered. So, can you read that? Mm-hmm. It's fairly small. Where the labels and values are unordered. So what's happened here is that you've got append to, and the result is that. So the result used to be over here. It's just moved around. Not quite sure how that happened, but it happened. So we're appending the list A, comma B to the list C, comma D. And the result should appear in X. Press the magic button. Click first, press the magic button, and then we get the result. Appending that to that results in the list, where are we? Here. Here we go, so A, comma B, comma C, comma D. Very nice. I just concatenated two lists together. Almost like a real programmer. And of course here we go, I've got a couple of other examples, so if you want to express some NARs in this prologue-like language, Raven inherits from bird. So you have the, what were these called again? There was that, an A and a C, the antecedent and the consequent was,
Yes.
you had big words anyway, so I used A and C instead. So, you know, the antecedent is the raven, the consequent is the bird, the copula is inheritance.
Oh, but here you can just say it's subject and predicate. Since this is not implication, this is inheritance.
Yeah.
So, yeah.
I was being lazy. The belief is that, and then in a later version of my language, I'm going to make these cool little sort of literals which can do really cool things. So, yeah, it should be fairly, is everyone sort of, does that make sort of perfect sense to everyone? Clear as mud? Same sort of thing, but this time using a probability. A raven is a bird, or this particular raven is a bird with a probability of 0.6. This is a literal. I've used a square bracket, a deciding character, then a whole bunch of characters in the closing square bracket as literal. And the idea is that you can write your own custom parsers to extend the language. And the same sort of thing again. So raven is a bird. The probability has the mean of 0.6 and a standard deviation of 0.3. For some sort of fancy probability theory that I haven't invented yet. Another example is mathematics. You want to say x plus y equals 4. I was playing with this. Didn't get much working, but the idea is that you can plug all the rules of mathematics into it and it sort of works like a theorem prover. So you ask it a question and it just pops out the answer. So that encoded into Squl is that awfully verbose thing. So the variable x, where are we going? N. The number of this plus that, what's that? Equal width. So the equal width is from the equal sign, and we have two arguments, n plus 4, where n is the variable x and the variable y. I can write down the parse tree for that. It is the same thing, really. I managed to get some simple equations being solved, but then I started working on something else. And the whole idea with the expressive completeness is that you've got to take any English sentence and convert it to this syntax. And this is my first attempt at it. I should get Eric to read this. He'd love reading it. Making a glass bottle releases more carbon dioxide into the atmosphere than making an aluminium can. So, yeah, this is my first attempt, and I'm not really slightly embarrassed to show it. Actually, I don't think it works. So, if the variable glass bottle is a glass bottle, and if the variable aluminum can is an aluminum can, and if the process of making the aluminum can releases that much of that gas, if the process of making the glass bottle releases that much of that gas, then that amount is greater than that amount. And yeah. So I was thinking about it a bit more for another 10 minutes, and I thought, well, you could probably just sort of black out the English, slightly parse or something. I don't know, I'll spend more time thinking about it. And then modules. So the idea when you're writing software and when you're working with stuff is that you want to modularize it. So I've got the modules. These are the modules I have here. And there's a whole bunch of other ones which do cool stuff like evolution and stuff. Each module is basically just a list of statements. And so they can import from each other. So you can either store your handwritten code in there. I've been writing an evolutionary algorithm over the last 3 days. That doesn't work. But the way it works is that you have basically a chain of modules, and they're all sorted by their fitness functions. So I've added a bit of metadata to the modules for a fitness value. Not the fitness, they're accumulation of reward values or something. And then as you're evolving them, you pick out 2 modules at a time, have sex with them, and then they make a little baby, and then you plug the baby in, resort it, and the reward functions are based on, I'll talk about in the slide later. So that's another way of using the modules. Alright, step 2 is to generate random knowledge. It's fairly straightforward, I didn't bother filling it in. So you've got the statements, and you've got heaps of stuff you can do. You can chop them up, you can slice them, you can mix them, you can toss them. You can just basically take 2 statements and make a third by choosing bits from each. Totally going to work. Of course it will work. Step 3, filter out the nonsense and keep the good generative knowledge. How do you know what nonsense is? The useful statements are the ones that were used in making actions that led to a reward. So when the fish gets food, it's kept a track of which statements it was using to, in the last however long, that led to it getting that food. And so it increments, each statement's got a little usefulness number on it, and it increments the usefulness. And I think the whole module itself, the module itself has a little reward value, which I was talking about before. So you increment that, and that makes that module more likely to be used in reproduction. Nonsense statements weren't used, get rid of them. And so I'm not, reward and punishment, I'm not entirely sure how, sort of, you were saying with NAS that you didn't want to use heuristics in it, or you didn't want to use any sort of...
Yeah, I don't use heuristics in the sense that there's no coding heuristic function to do evaluation. But there's some kind of idea. You can say that the heuristics are in the domain knowledge in the system.
Yeah.
The system will use the domain knowledge itself to get the resource distribution.
Yeah, so I'm not entirely sure how to implement an AI, well, even after these 2 weeks. that doesn't ultimately get a reward from its environment. So, yeah, I'm definitely using a reward and a punishment system as a heuristic to try and get the good behaviour out of my fish. Using that knowledge, now this is the part where I deviate from prologue. In prologue, when you have the rules, so you have conclusion, if, a premise, comma, premise. The way the prologue does input and output is that it replaces one of the premises with a command, now write out this to the network, or write out this to, standard output. And that's just pretty awful. So what I'm doing instead is that you have module, and then your module is considered to have logical statements outside of time. Anything in here is considered to be true for all time, and then outside, that was terrible. Outside that you've got some environment. How do you draw an environment? I don't know. I'm drawing a little fish pond. So here's my fish. Fish, there we go. And then you have this sort of interaction going on here. So what happens, and then we've got a timeline, which is divided up into what I call talks. And these little fellas here. So every talk has a tick before it, so it's tick tock, and then tick tock, and then tick tock. And that turns into statements which show the relationship between them all. So we're not so much worried about absolute timestamps. What we're worried about is the relative order of these things. Because when you're doing writing a logical program, you want to make sure that between this and this and this and this, there wasn't this sort of thing here which you didn't really find out about because you didn't do timestamp comparison or something. So it's very easy to say there's nothing between those two because there is no talk there. There's that talk and then that talk. These are, as the events come in, they each get their own sort of talk, and then it's impossible for an event to come in without it being related somewhere in the timeline there. And so you have the events from the environment being inserted. This is slightly wrong. You actually have two modules. And then that one here. So this is where your code is. And what happens is, as it's running, the events here get injected into this module, which is called the working module. And you also have the relationships between the ticks and the talks. And then after every talk, the environment does a query. All right, now what do I do? So the input is, for example, that statement here, which says I number 1 at those coordinates, at those RGB values, at that top value, at that talk. So it might be here, we saw that. And then the query would come through, what do I do? And these would, this is an import statement, so the data from both of these would be used. Your implementation would be here, the data would be here. This environment would say, right, at talk 1, 2, 3, 4, 5, 6, do X question mark, which is a query, and it's up to the code here to return a value for that query. It says, do that, move arm 1 to 45 degrees or whatever. Made up example, but you get the idea. And so it's in this constant loop with your module, and that way we avoid all the horrible prologue nonsense. And I'm going to skip that slide because you already just discussed that. So once I've got the, go back to one of these ones. Once I've got all of that working, then I'll start looking at the curiosity aspects of it, which will be interesting because if you're trying to form models of the environment and then trying to predict what happens, it'll actually end up in the fish physically doing stuff. So you'll actually see it sort of playing around trying to work out how it works and trying to form models of itself. Alright, any questions? Actually, I'll tell you what I'll do. I'll fire it with fish and we'll see if it does anything before it crashes. So this is the actual evolution code running. Yeah. It's using, the CPU's going hard out. Just leave it there and see what happens. So, any questions, or should we just go and have a party? It's 4:30 on the equivalent of a Friday.
We're talking about rewards and punishment, and that punishment is for that you give punishment for nonsense theories, and you're filtering out these nonsense theories. Am I getting it right?
The way that works, I need to make it more direct. At the moment, it's very indirect. If you have a nonsense theory, it's in a module, and that whole module is being evaluated as to how good it is at getting the fish to get food. And if it's not good, then the whole module gets removed. And if it is good, then it goes on and is used to make new modules using combining knowledge.
But do you think to convert this nonsense knowledge to negative knowledge, that you shouldn't do this?
That's a fantastic idea. When I get that running, I might think about it some more. But yes, it's counter-evidence, and stuff that doesn't work is also equally useful information. I haven't really got that far yet. There's a whole lot of things missing here. For example, at the moment, the evolutionary approach is crap. We all know that. I know very well it's not going to result in anything useful. It's going to crash soon. It's going to do garbage collections. What I need to do is look more into the evolutionary algorithms and get the mutation rules to actually do useful things. So, for example, yeah, it's crashed. So I'm going to stop it before it blows the computer up. It's all gone. We'll just pretend the computer's not fine. We'll just pretend it's fine. The whole structure, I'll draw a diagram of the whole thing. So, you have the fish. Right, and it's got its food. And here's a little fish. He's cute. He's got 3 eyes. He's got a little tail which tells him which way to go. And then you've got the modules down here. I think they're like 5,000 or something at the moment. Population size, which is why that's not working. And these are, the knowledge in these modules, that's the evolution. That's being all munched up and seriously doing a random search that doesn't produce any results. And this is going to be my special module, which is going to contain metadata to define evolution rules, which I haven't implemented. It's going to be awesome when it is. And that defines what rules are valid for the evolution. And in here, you can do all sorts of fancy things, such as, if you want it to do inference and abduction and pattern matching and all that sort of stuff, you can sort of code them up as evolution rules, or even cheat and hand code them. And then over here, you have this big sort of stored knowledge. Hand-coded stuff. So it's sort of like that, and that goes to and from there, and evolution, and then I think the top one here is the one which influences the environment. They all get a little bit of time with the environment each. So there's a lot of scope in the design of it for adding all of the features all the cool stuff that we've learned over the last 2 weeks. I haven't even thought about attention allocation or any of the really fancy stuff yet. You don't really need attention allocation when you've only got 3 senses. Yeah. Any other further questions?
Yeah. What is your idea for implementing a motivational system?
Motivation. It comes from the reward system, from the motivation of the fish is to get food. Do you mean more than that? Do you mean sort of...
Anything.
Yeah. At the moment, it's simply one-dimensional. There's only, just get food. That's all I want you to do. Later on, I can look at things like, do a bit of learning, do a bit of, go and hide next to the fire or something like that for a little while, because fish like fire. Or something, yeah. It's early days yet. I'm just trying to get the basics working. Everything's totally broken. Alright. Shall I hand back up to Pei?
Yeah, first comment about Prolog. It's also a program language I hate and love, both at the same moment. Yeah, on one aspect it's very excellent in certain aspects, but the other is horrible. Actually, the very first version of NARS was written in Prolog. Still, the current version, I have all the inference rules implemented to level 6 in Prolog, but only the inference rules, not the control mechanism. As you said, this backtracking control is horrible. That's the most horrible part. And also, of course, you can bypass it to rewrite your own control mechanism, but still the efficiency is very low. So one possibility I have been thinking, but on the other hand, to write inference rules in Prolog, that's much easier than any other language I know. And also knowledge representation is not too bad. So one possibility I've been thinking about, I never tried, is to use a combination of Prolog and something else. Use Prolog to write the rules and keep the knowledge, and use something else for the control method, and completely bypass this pattern.
Yes.
So that's clearly a possibility, but I don't really know whether that's a good thing. But on the other hand, another comment is, I think at the current stage, I don't want people to pay too much attention to which programming language to use. Actually, there's some debate in the past. People argue this language is better than. Well, at the current state, I think most of the AGI projects, including myself, most of the problem is still in the conceptual design. It's not really in implementation detail. It's way too early to settle down in a certain language. Claim that's the language for AGI. So also for your project, I would like to see more about your writing on the conceptual design aspect. How it compares with the other books. What do you think is the most original idea and you want to try in this?
So what do you want me to compare it with NARS and AERA and so forth? That was downright embarrassing.
You need to make the claim.
A more interesting comparison is with other artificial life systems or something. I would say this is really more like. I haven't been active in artificial life for a long time, but there's Polyworld. There's been all sorts of artificial life systems with the game Creatures, for example, evolving neural net creatures that go around learning and interacting.
Polyworld was actually evolving the physical bodies for the animals, was it not?
Not only, though.
Not only. I'm trying to limit myself to the brain here, which is why I'm taking knowledge and applying the evolutionary algorithm to it.
You know the game's Creatures?
Yeah, they had little small neural networks.
Yeah, they had a neural net being evolved by a GA inside them. And actually, Steve Grand prototyped, I think, never published a game, or maybe he did, I can't remember he was working on it. It was a follow-up to Creatures that was underwater, so it was actually fish with evolving neural networks going around. But I don't know if he ever did anything with it.
But I'm trying to have a single creature here rather than have a population which is mating with each other and so
makes
forth.
Such a big difference in terms of how the creature learns, I guess. So, whether you're going to have to have one or more of them.
Just to reply to your first comment, hey, one of the intent, obviously I know that the fish part of this isn't working very well, and it probably won't work for a long time yet. So, but the knowledge representation part is still working. Yeah, it's not really working. It doesn't like being. Yeah, I think it ran out of memory a few times. There's a few debaters down here now. I told you it would crash. There we go, now we're back to square one again. One of my intentions with making this language and so forth, because the evolution stuff is all experimentation, it's probably not going to work. The language will still remain useful. Earlier in the week, I was kind of intending to try to get maybe level 1, maybe even level 2 of NAS running on this as an example to show, but then I didn't, because I was trying to get the fish running instead. But yeah, in theory, you just plug all the NAS rules into here and it should just run inference fine. For a while. Right. 20 minutes left. Sorry, you're chairing. I should pass back to the chairperson.
Any more questions?
All right.
Well, I don't think it's only the knowledge representation that is important.
Yes.
Maybe the granularity of computation is also important.
Sorry?
Maybe the granularity of computation could also prove itself useful to consider.
The granularity of computation.
Yeah.
What are you computing?
The time it takes to perform an inference or to search.
Okay.
Since you are full steam ahead apparently in developing a new language and therefore an executive, you might as well consider the time cost for each task and to see if big ones could be broken down to the level of expenditure of the smallest one. It might give you some plasticity when it comes to scheduling. And this in Prolog is really pretty hard to achieve. It's impossible.
The way it works at the moment, well, it's Prolog, so it's sort of it's actually a very slow version of Prolog. You can have a module and you can fire any number of queries at it at the same time. In theory, it's multi-threaded. In practice, it's not, because the environment that I'm using only runs in a single thread, which is kind of really annoying. But there is no Smalltalk environment. Sorry, it's all written in Smalltalk. There's no Smalltalk environment which is currently multi-threaded. So, which is when I come to the dog, then I'm going to go seriously multi-threaded. The queries, when you do a query, you specify what limits you want to put on it. Otherwise, it would just potentially, not always, potentially just run infinitely long. And the limits I've done at the moment are time, so run for 5 seconds, run for 2 hours, whatever, or number of steps, or the depth of the search. So the number of steps, for example, runs it to so many inference steps, and usually find like 10,000 is a good number here to get results. The depth of the search I implemented for a reason that I've forgotten. I think it's when you wanted to, that's right, that's negation by failure. So if you wanted to prove there were no results, it's quite difficult because you end up with the system trying to prove, for an infinitely long time. So what you do instead is you specify depth and say only go, this many statements deep and then stop. But yeah, no, you could just run multiple queries at the same time, and it's just the higher level can then handle the granularity. When you say, think about, so I'm not entirely sure how to answer the question properly, so, yeah.
Thank you.
Okay, I think we should thank all the 4 speakers of today for sharing their ideas with us. Technically, this is the end of the summer school. But before I talk about what will happen to the next, I wonder if there's any other question from the other instructors or students. A couple of things I have in my mind is all the videos, they will be online after some editing and some processing. Some people ask for the PowerPoint files to be put online. I think like that will be done pretty soon. And the good thing is I don't have to say goodbye because as far as I know, most of you will stay, right, for AGI-13. So what's next today is we already have that banquet reserved at 5:30. Actually, it's in the hotel where some of us stay, where all the AGI-13 events will happen. Okay, so the idea is after this, they just kind of like work together to there. So for those of you who don't know where it is, just follow us, and you will find the place, and also you will know where to show up tomorrow morning. We will start tomorrow morning at 8:30, but hopefully you will show up a little bit earlier because we have registration and distribute the material and that kind of thing.
Can we make a photo, a final photo?
Photo, yes, we can have a photo. We have plenty of time to have a photo. Maybe right here, we can ask our professional photographers. And good idea. We can also have this sign.
You didn't get the certificates.